Okay, class. Today we will discuss simple microscope. A simple microscope is just a convex lens of short focal length held close to the eye. In today's class, we will write the expression for the magnifying power when the final image is formed at the least distance of distinct vision. Now, suppose when an object AB is placed between the focus capital F and the optical center O of the convex lens, a virtual erect and magnified image A dash B dash is formed. Now, since our normal human eye can see clearly at a distance of 25 centimeter, so we will adjust our lens in such a manner that the final image A dash B dash is formed at a distance of 25 centimeter, which is capital D, or you can say capital D as your least distance of distinct vision. Now we'll proceed to magnifying power. The magnifying power of simple microscope is defined as the ratio of the angle subtended by the image and the object at the eye when both are at least distance of distinct vision. Magnifying power small m therefore can be written as the ratio of angle subtended by the image at least distance of distinct vision capital D to angle subtended by the object at least distance of distinct vision capital D. Now what does this mean is, suppose my image A dash B dash. This image is at least distance of distinct vision capital D, and my image makes angle at the optical center O. Now this angle is beta. So my image A dash B dash makes angle beta, or I can say the image A dash B dash subtends angle beta at the optical center O. Similarly, suppose you have your object AB. Now what we will do is, we will place our object AB at least distance of distinct vision, that means at this point. So if I keep my object here, then let us say our object A dash B dash makes certain angle at the optical center O, or I can say the object A dash B dash subtend an angle alpha at the optical center O. Clear? Therefore, we know our magnifying power is the ratio of the angle subtended by the image at the least distance of distinct vision, which was beta to the angle subtended by the object which is at the least distance of distinct vision. This is my object. It makes an angle alpha. So I have written alpha. Now beta and alpha are very small angles. So instead of beta and alpha, I can write down tan beta, tan alpha. Now let us consider your triangle ABO. This triangle has an angle beta, and tan beta means your opposite side AB divided by your adjacent side OB. So instead of tan beta, I can write AB divided by OB. Similarly, consider your triangle A double dash B dash O. Now this triangle has angle alpha. So tan alpha is the opposite side A double dash B dash divided by your adjacent side OB. So tan alpha is A double dash B dash divided by OB dash. Clear? Now, since your object AB and A dash B dash are the same object, therefore they have the same height. If they have the same height, then I can write A double dash B dash equals to AB. So instead of A double dash B dash, I can write AB. Now simplifying, we will cancel the common terms AB and AB. OB dash goes to the numerator, OB to the denominator. Then we have OB dash divided by OB. Now OB dash is the least distance of distinct vision, capital D. So I'll write down minus D. Similarly, OB is the distance of the object X. So I'll write down minus X. Now I can cancel the minus term. So my magnifying power is M equals to D by X, where D is the least distance of distinct vision and X is the object distance. So for your homework, you can derive the magnifying power in terms of the image distance and the focal length. So that's it for today's class. Thank you, and the notes will be provided along with the video.